Okay, here's a quick video on graphing and asymptotes. So first thing I want to do is make sure everything is factored. Okay, if you're given something in standard form, like if I had something in standard form on the top, I want to make sure something doesn't simplify to like x plus 5 and create a hole in the graph, okay? So this one is nicely given to us in factored form already. So the next thing I want to do is I want to discover the degree. So the degree of the top is 1 and the bottom is 2. Degree is the biggest exponent. We'd get x squared down here if we were to go ahead and FOIL. So that means this is a proper rational function. So we would need to, for the vertical asymptote, remember that's the same for all proper, equal, improper, and the vertical asymptote is the 0, the denominator. So what would make that 0? The number 2, because 2 minus 2 is 0. And what would make this 0? That would be negative 5. And it would run right through there like that, okay? All right, horizontal asymptote. So that's the one where it changes depending on proper, improper, or equal. And we learned a trick in class that if we were to divide this, it tells us what the horizontal asymptote is. That makes the memorization piece a little bit easier for the hardest one. So a lot of you guys have memorized that this is 0. When it's proper, y equals 0. Okay, let me write in x first of all. So x was 2 and negative 5. But let's say I couldn't remember. Well, in order to divide this, I would have to FOIL the denominator to this. And remember, I would be dividing that into the numerator. And then the answer is going to be the horizontal or slant, if it's improper, asymptote. And immediately I can tell that x squared does not divide into x. And that's why this is 0. So remember, if they're equal, it's the ratio of the lead terms. That's why it's the ratio of the lead terms, because you're dividing them. And then again, if it's improper, I would get a slant asymptote if it was 1 greater. Okay, x-intercepts. So let me draw on the y here real quick. So the x-intercepts that's the 0 of the numerator. So remember, at some point in these problems, you need to figure out the 0 of the denominator and the 0 of the numerator. Y-intercept. Okay, y-intercept, we find that just like we would any y-intercept by making the x equal to 0. And when I do that, I get negative 4 over negative 10, which simplifies down to 4 over 10, which is 2 over 5. So that tells me that the y-intercept is about there, and my x-intercept is right there. Okay, we know a little bit more about the graph. So this is 0, 2/5. Very good. Now we need to actually go and graph it, which is actually easy. So in order to graph this, I already know the y-intercept. So I'm kind of wondering, is the graph up here or down here? Is it in region 1 or region 2? Well, since that point lies barely in region 1, I know that it is going to be hugging these lines and coming through here like this. And now I just have to wonder about the left and the right. Is it up here in 1 or over here in 2? Oops. So in order to do that, let me make sure I got everything drawn here again since I erased the y-axis. I need to test a point. So in order to test a point, I would need to choose an x value that is out here beyond the asymptote. So if I choose this and I get a positive number, that means that it's going to be doing this. If I test -6 that point and I get a negative number, it'll be doing that. So it's just a matter of plugging that point in. And what point is that? That's x is -6. So when I plug in -6, what happens? I would get -10 on the top, and then on the bottom I would get -8 times -1. So this would give me -10 over 8, which would give me -5 over 4. So that means that it is going down. I got a negative number. So it has to be down there in region number 2, okay? All right, sorry, my dog's being a little needy here. Okay, so, all right. Now we just have to graph the right part. So just like we did the left part, we're going to do it the exact same way. I'm wondering here or here. So I need to test a point. So I'm going to test just like this point right here, which is x is equal to, well, how far is that from 0? That's 3. So let's test x is 3. So I'd have 3 minus 4 over 3 minus 2 times 3 plus 5, which would give me negative 1 over 1 times 8. And that gives me, hold on a second, I'm testing 3, 1, 2, 3, 3 minus negative 1. That gives me a negative number. That gives me negative 1 over 8. So that tells me that when I'm going over 3, I'm just barely coming down here like this under the line. So that tells me that the graph is in the negative region because I got a negative number. If I wanted to be sure I didn't make a math mistake or something, I could then plug in something way out here, right? I could plug in this one. I could plug in any number, and all of them are going to give me negative numbers that would lie down in region number 2. All right, let's do another one. So that one was proper. Let's do an improper. So I'm going to do this one, which is improper. It's in factored form. Remember, I wanted to do that because I wanted to see if anything cancels, and it does immediately. That cancels out right there, and when we have that situation, that tells me that we have a hole at, it's not a very good at 4, because what would make that 0 be 4? I got a hole in the graph. Okay, there's one piece of information. Let's see what else we can get from this. So as soon as I do that, it is now simplified into a linear equation. This whole big thing now just suddenly became 3x plus 1. So I can spot my y-intercept. My x-intercept, okay. Well, it's not nice, it's right here. So again, x-intercept is 0 of the numerator. So I know this doesn't look like a fraction, but it's over 1, right? So what's the 0 of 3x plus 1? So what x value would give me 0? So I'd be thinking, okay, how do I make 3x plus 1? How do I make that 0? Well, I take away 1, and I divide by 3. And sure enough, see how this looks like it's about negative 1/3 over? But a faster way to do it that I've taught most people in class, and I've mentioned quite a few times, is when I have 3x plus 1, a really fast way to do that is I know it's just this number over this number and the opposite of that symbol. So 1/3 negative. All right, horizontal asymptote. So this one actually doesn't have one because it became linear, but it does have a hole at 4. So when x is 4, I need to carry this on so I can spot the hole. But when x is 4, I would need to put a hole like right there on my line, because it's going to be anything on that line except that value there. All right, so that is, so it's kind of like, you might write the hole for the vertical asymptote because that's kind of similar there. All right, so that is going to be, that will be that one. All right, anything else I wanted to do? Was there an improper one? Yes, okay. Improper kind. All right, so make sure it's factored. It is. All right. Make sure nothing cancels out. There's no holes in this graph. So let's get started. The vertical asymptote would be, maybe try this one on your own. Pause the video. Give it a shot. The vertical asymptote would be at 4. because that is the 0 of the denominator. The horizontal asymptote. Okay, so we are going to divide this one because this one is actually improper because the numerator is 3x squared minus 3x plus x minus 2. So I know that this whole thing in standard form is 3x squared minus 2x minus 2, and that is over x minus 4. So if I divide this, I'd have x minus 4, and I'm going to divide that into 3x squared minus 2x minus 2. Oh, wait, I wrote that in the wrong spot there. So I'm dividing that into 3x squared minus 2x minus 2. I'm pretty confident with our division skills, so I'm just going to cruise through here and do this. 10. And I'm going to divide, and I'm going to get what? I'm going to have plus 10. Okay, now I usually don't carry it out farther than this, but you can if you want to. And what happens is I'm left with some really big remainder, actually. So that part tends not to matter. All right, so what this means is that this part of it is the slant asymptote. So the slant asymptote is y is equal to 3x plus 10. And the vertical asymptote is located right here, but I already knew that, right? I knew that from the original problem. That's why I usually don't carry it out to the remainder, because as soon as I have my 3x plus 10, I'm good. So I know I got to go up 10 for this, so I'm going to lower my x-axis all the way down to here, and I'm going to go up 10. There's 5, and here's 10. And then my slope is 3. Now remember, this isn't part of the graph. This is the asymptote, like this. It's cruising right through there. Okay, oh, I have my y-intercept, right? My y-intercept is 0, 10. And my vertical asymptote was 4. Okay. Wow, this one really goes up a ways, doesn't it? So my problem here is that I see that this is coming up here, and I really need to be able to see this crisscross that's happening up there at the top. And I can't right now with the number of blocks that I have, all right? So this isn't going to happen on the test. But I can roll with it here on the video. So we're going to make each block worth 2. And I think that is going to give us the necessary room to kind of operate around here and let us get what we need to get out of the graph. So if each block was worth 2, the y-intercept would be at 5, which is really standing for 10, right? Because each block is worth 2. And then a slope of 3 would be, I could go like 6 up and 2 over, which is really 3 up and 1 over on this graph, like this. Okay, so it's going to come through here like this. And then my vertical asymptote is at 4, which is 2 blocks over. So actually my slant asymptote should also be dotted too, right? So let's just know that this is an asymptote. This isn't part of the graph. Okay, now we got more kind of what we need, because we need to see those crisscrossed regions, because that's where the graph is going to lie. So picture it kind of coming back here, going out there. Okay. So I know that the x-intercept is a 0, the numerator. So that would be the point 2, 0, because that's 2, right? And then the fancy trick I taught you before shows me that the other one is at negative 1/3, 0. So here's negative 1/3, 0 right there. And then the other one was 2, 0, which is right here. Now we got to remember that each block is worth 2, okay? So that means that that is right here. So I have one kind of on one side of the y-axis and the other one on the other side of the y-axis. So I'm kind of curious, when I plug in 0, where on this red line, this part right here, where is it going to end up? Because that's going to give me a pretty good idea, this is a tough one, of what the graph's going to look like. So I'm going to plug in 0 to the whole thing, and I should get what? So we'll take 0 and put it here, and here, and here. That's going to give me 1 times negative 2. That's going to give me negative 2 over negative 4, which is 1 over 2. So this one only goes up a half. It barely goes up at all. It goes up like here, okay? So that means that this must be coming through like that. Very good. So that means that the other one is doing the same thing up here in this region, but I need one exact point just to be sure. So I want to plug in x is 3 and see where it gives me on this line. How far up is that going to go? So what do I get when I plug the number 3 in? Well, I'm going to get 3 times 3 plus 1, and then I'm going to get 3 minus 2, and then I'm going to get 3 minus 4, and I'm going to get what? I'm going to have 3 minus 10, and I'm going to get a negative number. That's not good. So let me see here. That's why. Oh, okay. Math is never broken. So remember, each block is worth 2, right? So when I plugged in 3 right there, let me show you exactly what happened because it's kind of interesting. So again, when I plug in 3, I get 3 times 3 is 9, plus 1 is 10, and then 3 minus 2 is 1 over negative 1. So what I did was I basically got negative 10, which makes sense because look, like this is 3, okay? Out here, this isn't this, or what I plugged in here, this is 6 because each block is worth 2. So when I plugged in this, which is 3, I got negative 10, which is right there on my line, right? Now we got to actually plug in how many blocks over? Again, 2. We got to plug in, this is 6 because each block is worth 2. So when we plug in 6, let's hope we get a positive number that's going to tell me exactly where to plot it. So 3 times 6 is 18, plus 1 is 19, and 6 minus 2 is 4. And that is going to be over, let me make sure everything's right here. So 6 times 3 plus 1, 6 minus 2, this is going to be 2. And 19 times 4 is 38. 38 times 2 is 76. Divided by 2 is 38. So again, let me just write that out. That is going to be 76 divided by 2, which is 38. So this tells me that when I plug in 6, this is going to go all the way up, somewhere up here, to the point 638. Okay, so this is going to come way up here, and just giving me a general idea of what this looks like is really going to be good enough. Okay, but I know that it is some distance, right? It's not super. It's getting pretty jumbled here, but it's not really that close because I can tell that, you know, this is quite a bit distance from the intersection. So 6, 38, this is going to be a little bit of a distance away too, kind of coming through like that. And just giving a rough idea what these look like at this point is good enough. That was a really tough one, but hopefully you could follow it. And if you have any questions, please feel free to ask me in class when you see